today's video, we are going to look at nesting and optimization using the Nesting Manager. Nesting Manager was introduced in V28 and you will find it under Tools and Nesting Manager. In this window, panels and beams will be placed in different tabs, and actual panel will be separated from nesting groups and nesting result. So you will find your panels and beams in the tabs of the same name, and it displays all elements currently displayed on screen. This means that if, for example, we would like to focus only on the nesting of the glue lamp and the CLT, we can actually interact with the elements behind, control by material, and then we hide the rest. You see that it automatically updates the element available for the nesting or the optimization in the case of the beams. So here we are going to start with a panel and focus on the CLT roof panels. Here you see that each line corresponds to a specific element of a specific material and thickness or sections in the case of a beam. And you can actually select this line to select all elements inside. You see there is a white highlight on the element in the 3D. This means these are the elements from that line, and white means that they are currently not grouped. To create a nesting group, you can either select the elements like we just did, or select directly the elements within the 3D. And then select the corresponding line and create a new nesting panel. In our case here, we will simply create a nesting panel including all of the panels. So we select everything and then create new panel nesting. So panel nesting will be automatically named after the element's material and thickness. So here CLT 7 inches. Let's start with the right side. The right side is where all the default options will be found. So this is not something we will be interested in today. This video will be only about the nesting manager and the automated features. But basically this allows you to create nesting based on your elements. So it will create nesting for each of your elements, or create nesting in which you will place your element manually afterwards. But this is something that is done directly in the nesting manager. This is only the options to generate those. So here we will have different types of calculation. No optimization. It means that everything will be done then manually by the user using then of course this default setting just introduced. Then with length optimization, so it's an optimization in only one direction, so along the length of the panel. And here we will be able to set the name of the rough volume, so the nesting panel. And here we are going to set it at, for example, 60 feet long, 10 feet wide, and a cut width of 1/4 of an inch. We can then choose the name of that panel using either existing names for CLT names or create new ones right below. And then there is a third option that we are going to look at the end of the video. It's instead of using the nesting routine from Cadwork 3D, we will be using external nesting programs such as OptiPanel, which you can ask for a trial version by clicking here. So with length optimization, okay, this is correct. And now we are going to create the nesting group. So now you see that the nesting group has been created. So it will be available right in the first tab. But if we go back to the panel tab and reselect these elements, you see that now the highlight is no longer white but orange. It means that these elements are part of a nesting group and have been nested. If they were not nested, the highlight will be yellow. So here if we go to the nesting panel, we have information about each available nesting group and their current state. So for example, if I select this one, I have its name, I have the total amount of element inside, so you can use that to interact with the model behind. So you could see which element is unnested, etc., etc. Then right below you have the actual nesting information, so how many nesting volume were used for that group, and the total area that is used at the end, so the total area of all the panels, the used area with the ratio, and of course the waste. Now that we've seen all this, we can actually enter the nesting module. So either by double clicking on this group, or simply when selected, click on open. Okay, so here all the elements were placed automatically inside nesting volume of the requested dimensions. And here, if we go to attribute display, just to display the production numbers of nesting volume and nested elements. So you see the different numbers, and here you see that for nesting volumes, the production number is not right in the middle, but always on the bottom left, to give you a bit more. It's easier to read and avoid overlapping with any other information. And nesting volume production numbers is always starting at 2 million. Once you are in this window, you can of course change or move elements in different from nesting volume to another, or move them inside. If you would like, for example, to bring this one lower to start the cut right at the bottom. So you can reorganize your elements, create new ones, delete existing ones. For example, if we would like to take this one out and replace it with this one, and here, 5x 1/4. Okay, so, and then this one here can be deleted, so active delete empty nesting volumes. Okay, so this one now is no longer associated with anything, so I could add a nesting volume manually. So here I can either use the length optimization. So here again, it's exactly the same as we had earlier. So, but you will be able to set a new dimension, and what is added here matches the dimension of that panel. So if we go with with directly the element above, and so 7 by, let's say, 23 feet, cut width can add 0. So here, like this, it creates something right for these elements. So when the nesting is ready, you can either export nesting shop drawing. So this is exactly the same setting as you would have we've seen in the different export available in Cadwork 3D. So here we won't really go in depth in the setting. There is nothing really different than the other ones. So of course you have automated dimensions and label settings. So this is pretty common for exports, and let's just have a look at the result we could expect. So here we have information about production number of the elements, all the different dimensions, grain direction for the main panel, etc., etc. So we won't really go far in the export settings, and here also you see that at the top you always know which nesting group you are looking at. So currently we are in the CLT 7. So here, now that everything is done, we are just going to exit. And now let's focus on the beams. Let's start with the post. So one thing important when you start the beam optimization or beam nesting is to know what number should be taken into account. So basically, it's the shape of the element that should be considered. So production numbers will use real dimension, and part number will use rough dimensions. So here you see that in one of the previous video we've set a rough length to all the glulam elements. And this is what we would like to take into account in that optimization. So we would be using, in that case, the part number for the optimization of these elements. So here, make sure to select part list, and when I'm ready, I can create new beam nesting. So here I have the group, so it's the same logic as earlier, so the name and the section. And here the only difference is we only have two nesting options, so no optimization or length optimization. There is no external program for this. And create nesting group. It's exactly the same window we've seen in the list optimization. It's exactly the same. The only difference is here the optimization is done directly within the 3D, meaning that the information about the nesting is kept and saved inside the 3D, unlike the optimization from the list that generates only a text file that is not in any case linked to the 3D elements. So here we are going to use this default option, so 1/4 saw curve, and we will remove 1 inch at the front and the end of the beam. We won't use the automated stock, and we are going to use a specific length of, for example, 60 feet. Enter to create a new length, so 45 feet and 30 feet. So if we don't set any piece number, it's just an unlimited amount of stock. And here we are going to run the optimization. No, we don't want to edit the stock, so like this you can manage your own stock. Okay, so once done, we see here that as the same as earlier, now the highlight is orange, meaning that these elements have been nested. So if I go back to the beam nesting here, I have all the information, so it's exactly the same kind of information we've seen earlier for the nesting, except that now here next to the name we have the information whether on what number this has been done, so part list or production list. And here open. So here we have the result of the optimization. Here you see, as soon as you have several nesting groups, you can actually go back and forth and basically look at work in all your different nesting. You don't need to go back to the nesting manager to re-enter the modules. You can directly go from one to another directly within the nesting. And now let's do this one. So the girts, always part list. Always remember which number should be considered. And here the only difference is that we are going to set a specific stock. So here, for example, 60, I have 2 of them. 40, I have 3 of them. Okay, and let's run the optimization. Still no stock update. So here everything was nested again, and here we can open the result. Okay, so now that we have all this information within the 3D, it's important to know that you can actually export this in lists. So always remember what number was used, because it dictates which list should be used. So here, if we, for example, select our panels and go export list production list and list output, it will be asked if we want to output the nesting volumes. So let's say yes. CLT nesting. Okay, so here I'm just erasing an existing one and I'm not using its settings. So let's see what we have here. So this is I'm using the production list setting, and here we see all the different nesting panels. One thing that's normally when we have nesting or optimization, we have a drop-down list that shows you what elements are inside. But this is only if these elements are displayed or visible in the list. So here, in order to see our roof element, we are going to make sure that in the settings, in visible elements, solid roof are actually displayed. Apply and OK. So now that they are, I can unfold everything, and here I have information about all the nesting and their sub-elements, or child element, as we would call them. So this is for the CLT nesting list. So now if we focus on the beams, so by material, export, list, it was a part list, list output, and here you see we will have output bars. Okay. Okay, so here we have information about all the glulam elements. All the glulam elements, so these ones are the ones that have not been nested. And here we have our different elements, so the post and then the guts, with each one information about element inside. So remember that these nesting elements and bars are also elements, like visible elements. So if you don't want to display this information, like the orange lines in your list, you just need to go to visible elements and simply hide the optimized bar according to the part list in that case. Okay, and here you go back to a regular cut list. There is also a setting, so if we go in load settings, that is done especially for optimization. So if you go back once and go to init and you take this one, so init stange TL, so this is the init used for the optimization. So here it's just the column that are a bit different, and you will have information about the bar lengths and bar of cut, etc., etc. So this is really done really especially for optimization, to have basically all the information we've seen in the nesting manager, basically, but for all individual elements instead of for the whole group. Yeah, we'll save this one. Okay. You can also go to lists and optimization. Since the optimization was, even if done through the nesting manager, the information is still in the 3D. So here you would just need to tell which optimization should be taken into account, and here we have the different results among the elements from the 3D. So here you can still go display bar list, and this will export a list automatically using the same setting we just used, but automatically. Okay. So now, if we go back to the nesting manager, here we are just going to delete this one. Yes. Go back to panel, CLT, create new nesting, and with external nesting. So here I'm going to create nesting group, and this will directly run a position check and open the OptiPanel software. So here we will need to create, I will just clean this by deleting. I'll just delete this to start anew. And what this is doing is it will use a specific stock that we will create right now. And of course, you can use something specific already existing or running an import via from CSV file or something like this. So here we are going to create our new storage. So here currently this software is only working in metric, so we are just going to adapt this based on our elements. If we come here to panel management, you will see that we have all the different panels that we have imported with metric values. So here to create a new panel, I will just simply click on plus and create a name. So for example, CLT 7 inches, its width will be 30-50 millimeter and 15 to 40 long. The thickness will be 177.8 millimeter. Material is CLT. This is really important. It has to match, of course, the material set in Cadwork 3D. Then here you see that you could set also the price for the volumic price, the surface price of your element, and here if you'd like also set a specific quantity for each element. So here, since everything will be nested in this, we will just set it as unlimited for this example and add panel. So now we have the rough dimensions here and the panel here at the top. Now let's move to the panel management, and here you have all your panels that were imported, so all the panels from your nesting group. By clicking here on the gears, you can change the table settings. So for example, here I do not need the group or subgroup, and okay. So here, flippable on itself is just whether or not the element can be flipped. And here the fiber direction is if the element should be along the width or the length of the nesting panel. So here, for example, we could say everything to length, or just say none if it doesn't really matter. Based on the rough dimension of our element, anyway, it will have to be in length. We cannot nest it in the other direction. So in our case, it won't change anything to our result. When this is done, simply go to optimization. Here you will have several options such as the cutting direction. So if you remember, the only earlier when we've made the nesting, we had two elements in the same nesting panel, and they were separated by a vertical cut. So here, if I say only an horizontal cut, these two elements won't be placed in the same nesting panel because I authorize only horizontal cuts. So therefore, they will be placed in an extra panel. Or here, you can set also only vertical, and in our case here, we would simply set it as indifferent. You can take here the as we add the same way we set in the nesting manager, you will also be able here to set the saw cut thickness, the edge around the board, and the machining price as well. Here there is some interested options. Some of them are part of the professional version of OptiPanel, such as use free placement algorithm. It means that elements that are not rectangular, so triangular shaped and etc., will be able to be nested together by taking into account these cuts. Currently here in the classic version, only rectangular shapes are taken into account. So if we have a triangular panel, we will take into account its rectangular overall shape. Then the last one here is use opening. It just means that you can nest element within panel openings. And here this one is recover drops. So leftovers from nesting can be kept, and if you'd like, it can be automatically added to your stock for your next optimization. And here at the bottom it's just the calculation setting. So if you want a fast calculation or better results, so it's just the number of iterations that will be done during the calculation. And here, just when everything is done, just click on optimization. So now here you have the different results. So each panel has a tab. So and here we have the summary of these elements. So here just, yep. We have used all 8 of our panels. We used 7 row panel. The total area is available here, and total amount of drops and their rate. You can look through the different settings, the different results by using these arrows, and here you see on the what is in red here might not be the same on your side. This is just linked to the option to recover drop. So basically the drops here are dimensioned and will be numbered for later use. When if I'm good with my result and I want to bring these information into Cadwork 3D, I just need to click here on the check mark and close. And now if I go back here to Nesting Manager, I will be able to open my result and see the result from OptiPanel. Once added in Cadwork 3D, it's exactly the same as an optimization built directly inside Cadwork 3D. So everything that we've seen so far, so with list export or management of the nesting elements directly within the Nesting Manager, hasn't changed and will be also available with OptiPanel. In the Nesting Manager, there is another tab that can be really interesting and pretty useful. There is here the create nesting groups by attributes. Instead of using material and sections or manual selection to create your groups, you could base this on existing attributes. For example, if let's close this for a moment, and let's say this will be placed in a group called like small roof, for example, and this one will be main roof. Okay, so if I go back to the nesting manager, so you see here there are always, oh, I will delete this because I did not press apply earlier. So here they are still together, but if I go to other and generate, will be asked what type of element should I consider, so panels or beams. So here I will select only panels, and here, oh, I have 36 panels, so here always make sure to select only the elements you want to consider for this. Generate. Okay, so here I'm not asked if I want to consider beam or panel because only panels are visible currently. So here I have 8 panels, and if I click generate right now, only material and thickness is taken into account. So here I can choose from any attributes available from this list. So basically this is the main attributes and user defined attributes. So here I will use the group, and you see as soon as you add an attribute, it will be added a specific prefix like 1, 2, 3, etc., etc. And this is simply used for the name of your new group. So here we have 2 and 3. It's not used here, so these will just be empty, but of course we can still remove them. if needed. So basically here my name of my nesting groups will be small roof CLT7 and main roof CLT7. And here I would go with yeah, why not? No optimization. It's not really what interesting here, and generate. So now you see that we have the main and the small roof grouped in different subgroups. Then still in this tab we have manage nesting volume numbers. So this allows you to these ones don't have any numbers because there is no nesting volumes inside currently, but you see if each nesting volume has a number, and for each groups there is like 1,000. For example, this one is the first beam group, so 1,000. This one, the second one, 2,000, and then all the elements inside are number 1, 2, 3, etc., etc. So you just need to switch them, and you can renumber all or renumber only the one selected. So it will automatically readjust the numeration and the element within, of course. And here the last one is simply a way for you to change the default setting available when you create new groups. And that's it for the nesting manager.